On today's small block Chevy episode on Crazed Performance Repair, we are actually going to work on doing the cylinder head, trying to figure out what length push rods we're going to need for this motor, and overall Valvetrain talk. So be sure, stay tuned, and we will get right on the subject of the Valvetrain for this particular vehicle. So you can see I'm a lot further along on this particular episode already. I skipped quite a bit. I got one cylinder head installed. I did not torque the head studs yet. I pre-torqued them. I set in at like 30 foot-pounds or something. So the head studs are at 30 foot-pounds only. I slid the cam into place. I also went ahead and got the lifters sitting in place as well. If you want to learn a little bit more about sliding the cam in place, what I do to prepare for a cam install. Now this is a full roller motor. So it's going to be identical to another video where I installed cam bearings. So be sure to go ahead and check that video out in the link above later on in the video. So in that video, I go over several things related to installing the camshaft. On here, we have a little timing belt kit that we're putting in. And we're going to talk a little bit briefly about that quick today. Just because I happen to have it installed on here, and I know you're going to be curious about it. So this is actually a Comp Cams timing belt kit for a small block Chevy. Why would I choose to go with a belt kit for a small block Chevy? Well, in a high performance application like this, the cam lobe profile on this particular motor is quite aggressive. It's like if you were to look down the cam, it has a really small base circle, right? And then the cam lobe itself is just like an elongated, it's almost a rectangle. The top of it isn't squared off, obviously, and the bottom is round too, but it's like a very elongated circle, I guess you could call it. It's not at all a circle, but it's not like a normal cam lobe. It's almost parallel where the ramps are. So being an aggressive cam profile, there's going to be a little more Valvetrain noise. Furthermore, noise from the pistons and everything else when all the explosions are happening happens in the crank. So there's harmonics going into the crank there. The pump that is driven over here is going to be pulling a lot of power. The pump that's driven off the distributor, because the pump's going to be a high pressure, high volume pump. We want this thing to rev out to a pretty high RPM, and because of that, it's going to draw a significant amount of torque on the camshaft setup. So we went with a belt drive because the belt drive is going to be not only stable, it's going to be consistent, it's not going to shift, there's no slop in it, it's tight all the time. But the best part about it is this rubber acts as a dampener, so it actually dampens a lot of the Valvetrain noise and any other harmonics that come from the crankshaft that are going on. So it increases the life of the Valvetrain, and that's why I go with a setup like this, if I can. If the customer's willing to pay for something like this, we will put something like this in. It's a much better setup. It increases reliability, reduces all the noise, all the things I just explained to you. So that's why this guy is going to be in there. Obviously, I don't have the bottom pulley on there quite yet, but I will be putting that on and degreeing it here as soon as I get the seal to install on the bottom half. That's the only reason that's not on there today. For now, we're going to go ahead and get this cylinder head installed. Now, I do have a special item that I put between the head and the block on this motor because this thing is going to see a power adder at some point, and there is talk of cranking it up to 1500 horsepower, which is what I'm building it for. So this is going to be seeing not only head studs, obviously, but we're putting a copper gasket on here. Now, normally when you do a copper gasket, you have to put power O-rings in here in order for the copper gasket to hold up and not leak. But there is a gasket company out there that makes a gasket made out of copper that does not require power rings. And it's a very cool, unique design. And I'll go ahead and throw a picture up here of what it looks like. But basically there's a wire inside the gasket, and that wire that is inside this part of the gasket here, when the explosion happens, it pushes that wire, and that wire expands the copper. So it adds pressure to the copper, which makes it seal. So it acts like a power O-ring, but it's built into the head gasket itself. Super awesome design. Unique specifically to the SCE ICS Titan, I think is what it's called. I don't know. I'll put it up here in the corner somewhere. But this gasket is a very awesome design. Works really well. I had a small block Chevy that was not a dart block that we were having head gasket trouble with the block flexing and so forth. It was a 355 small block Chevy, and we were spraying it with nitrous. Well, we sprayed it with a 200 shot. It was fine. The moment we hit it with a 225 shot of nitrous, it would spray out of the head gasket. That was with a MLS head gasket. So it would puke out just a little bit of antifreeze. It was spraying out the one corner coming this direction. It went through the combustion chamber and out, and it just would not handle it. We put one of these gaskets on, and we were able to hit it with a 300 shot without a problem. So it worked really well to seal that little guy up. That motor was not the best motor. Yeah, I could have did a better job building it. That was when I was first started playing around with this stuff. It was all my experiments and trying things. But that motor did okay, considering how inexperienced I was at the time. So now I have figured out all these little things like this gasket. Rather expensive, well worth the investment. It holds up very well. Now this gasket does have a head side on it, so we need to make sure it's facing that head side. Label faces up. I see, you guys can't see it. I see like a reflection from the light. There's a spot in the copper here that's got a little bit of a ripple to it. If you see that, it won't hurt these gaskets much. Because of the way they're designed, this part, the ring that's around here, is raised significantly above the copper here because of the wire that they shove inside there. So that won't affect much, because as soon as you torque it down, it'll flatten everything out and squish it against that stainless wire that's inside of the bore there. So I'm going to go ahead and grab the head. This is a install it dry head gasket. I already took and cleaned off this surface as best I could to make sure that this guy is going to be nice and clean, dry, no oil, nothing on it. We're just going to leave it clean and dry. We're going to drop this guy on the little dowels here, and then I'm going to go ahead and grab the head and drop it on top of here. I also took the head, cleaned it off, dried it, made sure it's in its proper state as well. Now, if you like, you could put a small dabble of RTV in the corners here. So I'm going to actually go ahead and throw a little sealer in there. I see the gasket here does not have this silicone stuff going up this diagonal to match this part of the block. So I'm just going to put a real small amount here. And I could probably even use anaerobic if I wanted. But I'll put a real thin film with my finger over the surface of the block here, right where that sits. That'll be good enough, and I'll throw the head on. Now I have these bolts in here. I actually had to leak test this cylinder head because this one has been used quite a bit. And so I had to make sure that I didn't have any leaks somewhere and take care of those before I put the head on. Head bolts or head studs? What do you need to run, and when do you need to run it? When it comes to head bolts, the factory head bolts are pretty decent. I mean, they work for most applications. If you're doing something stock or even mildly performance, fine. Use a regular head bolt if you like. It's not going to cause any problems for you. They'll work perfectly fine. But if you would like a little extra clamping force to make sure it's on there properly, you're going to have to go with studs. Now, if you're not looking for more clamping force, you just want it to be a little bit stiffer overall block, you can get the ARP head bolts. They do stiffen things up a little bit, but the studs are by far superior to the bolts. And why is that? So you can see the stud here. This is the coarse thread. This is the part that's on the block. It's a very, very coarse thread. Well, on the other end here, we have a very fine thread. Now, this fine thread is what gives it all that extra clamping power, because you thread this guy into the block, and then the nut that goes on here threads down, and this fine thread applies a lot more torque to the cylinder head. Because you're applying more torque, it's obviously going to be able to hold it down a lot better. So we're going to go ahead and throw all these studs in here. There are 3 different lengths, and for each head, there's going to be 2 of this mid-length, and then these are the short ones that go on this end over here, and then this long one goes on all the rest. So the 2 that are the mid-length go on the ends here. There's a little drop down where the oil drains down on small block Chevy cylinder heads. 23-degree heads specifically. I don't know about all the others. So those guys go on the ends there. And then, of course, the long ones go everywhere else on this half. And the short ones go where I just told you, on the outside. So I got all the head studs sitting in place. I quickly realized, when I did it on video there, I actually put them in this hole, which is a drain hole. Dork me. It's supposed to be over here, but whatever. So I got all of them sitting in place. Now, what am I going to do to tighten these things down? All I'm going to do is take this thing and thread it in by hand like this, right? And then take it and just snug it. That's it. You can put Loctite on it if you like. It's not necessary, but the instructions per ARP are obviously saying that as well. So I'm just going to go ahead, snug them down like this. And this particular cylinder head, now this is an Edelbrock head, but right here, this area, you can see there's these cutouts on the actual spring things there themselves. The washer for this one won't fit in there if I go ahead and put this in. So I have to leave this one out for now, and then I have to slide the washer. Now the washer, I'm probably going to have to put little notches in it as well, just in order to get that in there. And likewise, the end ones here as well. You can see I have the spring-based cutaway here. I'm going to have these sit aside in order for me to slide the washer in first, then push this through the washer and put it in. So I'm going to leave those ones out, and then get the washers on those, and get all these studs tightened down the way I need them, and then we'll be right back to torque the head down. Now what do I do when I apply the ARP stud lube? Now this is a kind of a tricky thing. You notice I didn't lube anything before I put it in. You could lube the threads of these before you drop these down into place. You could also go ahead and lube the washer. All I do is I take a little bit of this ARP lube, I push some of it into the threads, and then I make sure I leave a little bit sticking outward off the threads as well. Because by doing that, what happens is when you start threading the nut down, it threads down on there, and it actually grabs a hold of some of it, threads it onto the threads, and then some of it stays on the main flat. I'll go ahead and pull this off here. Probably shouldn't do that with the stuff all over my fingers. I put a little less on this one on purpose. See, some of it is going to stay on the bottom here, so that when it hits that nut, it's actually going to go ahead and squish down and outside of the area there. So I'm going to just snug it with my fingers, nothing crazy. You see how I grabbed the nut? That's because the lube, you can actually see a little bit, is piddling out there. The lube is actually squished up against that nut. So it's going to do what it's intended to do, which is slide on the nut there. So kind of a little thing I've learned to stop wasting so much time farting around with adding extra lube that you don't need to. This one I did a little less on purpose, but it still functioned perfectly fine. What I like to do is leave a little bit extra like that, but I typically do that on the inside ones. On small block Chevy, on the outside ones, if you do this, it ends up leaving quite a bit of a gob sticking out here, and of course that collects dirt and dust, which isn't ideal, at least until you clean the motor. Once you clean it, then that comes off and these things start to rust, which also sucks in a way. But you can only avoid so many issues. You get rid of one issue and you have another issue. So be it, is what it is. I'm going to go ahead and finish this up and then start torquing. So now when tightening these down, the first little part, now I just started the thread, except for this one I couldn't finger thread that one on. It's interfering with this little spring cap thing, or spring base thing. So this one I already just took and I snugged up just a little bit. Not much. It's very, very loose, maybe 10, 15 foot-pounds tops. And all I'm doing is I'm starting in the middle, and I'm going to work my way around. So I'm just going to barely bring them to the bottom. This is kind of a cross-torque pattern I have going. I'm going to go ahead and grab my torque wrench and actually start torquing it down. I'm just going to do a first stage, which I'm just going to throw 25 at it just because. I just want to get it snugged down for now. Since this is such a low amount of torque that I'm doing, I'm going to not worry too much about doing a cross pattern. Just start from the middle and work my way to the outside. And you can see I'm hitting the middle a second time here, just to make sure that I get them all snugged up. Because as I tighten these down, the middles loosen up. And now I'm just going to go from left to right, since I already snugged all of them up, just to double check them all. That way I won't lose track of any of them. So now, what I need to do is start setting up the Valvetrain here. As far as actual measurements, I need to figure out my push rod length, I need to get the rocker arms in place, I need to figure out my rocker geometry, things like that. And there's kind of somewhat easier ways to do that don't require all the crazy science. You can go into depth on the crazy science if you want. Feel free to go ahead in the description below, or not the description below, but the comments below, and fill up the comment section if you know a bunch of scientific crapolas about it. But basically your goal here is to make sure that the rocker roller, that I'm going to be using roller rockers, a shaft mount roller rocker system, make sure the rocker roller rides in the center of this guy. Now you're going to have to change the height of where the rockers are sitting at, and the push rod is going to determine what that height is going to be, as well as where it rides on here. So it's kind of a combination, and all I do is I play around with different combinations, trying to play with things. I have an adjustable push rod that I use to figure that out. But what I found, in order to get that proper geometry, over time, I've kind of figured out how much lift, what rocker ratio. In my head, I kind of auto-calculate it as to how far back during the relaxed state that rocker roller has to be for it to land going about midway on average of the stem here, to make sure that it rides in the proper spot of the stem. And this particular engine is going to be seeing 680 thousandths of an inch of lift, and then it's going to be on a 1.5 to 1 rocker ratio. So it's a very low rocker ratio, which is why this is cut out here, because the push rods sit back quite a ways, and otherwise the push rods will hit this. So this particular combination has been done before with a little bit more stroke on the same exact block. So I already know pretty much what I need to do for shims to get this right, and it did cause a lot of Valvetrain issues for us on this build. This was probably my second build when I originally did this setup, and it made less power, of course, at that time. But right now, I know how to get this thing set up so it actually lasts and work a little bit better than that particular build did. So that's what I'm doing on this one. I'm taking my old build that I did a long time ago and fixing all the little minor issues that we had with it so that it becomes a much more reliable build. So this one, we're going to have the rocker and the push rod's going to come really close to here. The rocker might have to be clearanced on the valve cover depending on the valve covers that I put on here, so I'm going to have to worry about that. As well as these rockers have already been clearanced for this large hat on this valve string retainer. So sometimes you'll have an issue with that. If you can avoid that issue, if you find that you have that issue, either try changing to a different hat. Unlike this one, this build, like I said, again, the first iteration of it was a crummy setup. Did not work very well. It worked. It certainly worked, and we got quite a few miles out of it. But it did have its fair share of Valvetrain issues, and that's what I'm resolving now. But this little section here, I had to carve out a chunk on the rocker to make up for it because it did interfere halfway down the pushing part of it. It would just touch the rocker, and of course that causes issues. And then, like I was saying, you want to ride in the center of this. I did get that to work properly. A couple of these stems did not get, they still have a little marks on them, and I can see where the marks are. And the mark that would be on it, it goes from approximately right here to here. So it's dead center where it's supposed to be. And what I need to do is I need to try and get this one so that when that rocker is in the right position, it's going to land right here for the center of the roller, where the roller actually rides. I want it to be here. And I'm going to grease this. I'm going to turn the motor over and watch what it does. And depending on what it does, it's going to depend on the shims that I put in here and the length of the push rod that's going to be in here, because these are also adjustable rockers that are going to be on here. So I'm going to go ahead, get everything torqued down, get this head taken care of. I'm going to get the shaft mount rockers, one set on here, and some push rods. And then, of course, I have to address the timing control on the front of this thing, that seal. And once I have all that, we will be right back to go over how I'm going to set this up. So I'm currently in the position where I am trying to get all the Valvetrain set up. I know I had told you guys that I was going to go through setting up the procedure for the length of the push rods, but it turns out all the specs that I had on the previous, when this cylinder head was on this block, and with that cam, I happen to have the old push rods laying around too, so I already got the proper length. So I pretty much have everything I need, and it's all set up. I even had the shims laid out for these deals the way that they were before. Now the shims go underneath here. For those of you who don't know, goes where this main bar that goes across here bolts on to the head. And this Jessel system, I really honestly wished originally, when we built the motor the first time for the other customer, that it had been done for the experimental customer, I guess you could call it. It had been done with a different rocker ratio, because this cam at 680 lift is too much lift for these heads, and the valve relief or the spring relief has been cut down to make room so there's no spring bindage, if you will, going on. And of course that caused other issues. And then of course, since the rocker ratio is a 1.5 instead of a 1.6, it makes this out further, which caused us to cut this out. So if you're doing any modifications where you're getting excessive lift on an engine, things like that, you really have to pay close attention to how you're setting it up. And it's best to have somebody experienced or has done the setup already once before do it for you the first time you go to do it. Get you the proper parts, or buy a kit that comes with everything you need. But in heavy or high lift situations where you're getting an excessive amount of lift, you want to make sure that you just plain and simply know what you're doing and know how to check everything. It gets a little bit complicated when you get up in the higher lift areas. Now, this particular motor, I never talked about this yet with it, but these lifters are a custom-made lifter that we had special ordered. And they are a roller lifter, yes, but they don't have bearings in here. Most roller lifters will have a needle bearing down in this area. This actually has a brass bushing rather than a roller needle bearing. Why did I go with a brass bushing? Well, with the lift and the harmonics and everything going on because of how fast this cam lobe ramps up on this particular cam, I wanted to make sure that these things aren't going to fatigue and wear over time. Plus, the steel material that these are made out of is a much better material than, like, say, a comp roller lifter. So, one thing you do want to make sure is that you get a very high quality roller lifter. This is from Jones Cams. They actually make a set of lifters. They're very, very high quality lifters. And of course, these are a solid roller lifter, so there's no hydraulic in here. But I go through companies like Jones that do custom lifters because you can get a much better quality product. This brace is stronger. The steel that they use is better. The fact that they give a nicer washer and this head unit here for where this slides works a lot better than like a comp lifter or something. But they do come with a premium price tag. For a comp or whatever lifter you can get at like a Jegs or a Summit, those lifters, you're looking somewhere between $400 and $600. This set of lifters is closer to $800. So these do add up in price, but when you go with a custom lifter, again, you're getting a much better product. And lifters are one of those things that I learned the hard way, that the cheap ones for engines specifically like this one here are not a good idea to go with. Now, as of right now, I have all the push rods in. I have only this set of rockers set with the lash, and I have this one, obviously, without push rods in it. I left it in that position just so I can kind of cover a couple of things with you guys. Now, the rest of these, I have all the nuts loose except for these two here. These ones are tight because those should be set. I'll be double checking everything again. But I got to set all these up for the proper lash. And then, of course, this one here is the one that I don't have the push rods in. So I'm going to do that on camera really quick, just to show you guys kind of the procedure for that. So I have here my tub of racing assembly lube. I just dip one end in the racing assembly lube. That's going to be the end going down into the lifter itself. This end here, I took the racing assembly lube and stuck it in the end where this is going to go in. And I do that for the reason of keeping my fingers from getting covered in the grease. So that'll prevent me from making a mess on myself here and allow me to still get this thing installed and lubed up. Now, you can see I got grease on here now. That's because the grease was in that cup like I was telling you. And then, of course, I'll be able to thread this down. But these guys, these nuts are tight on this one because I never took them loose yet. But rather than try mounting them in a vise or something to take them loose, I am just going to go ahead, run this down until it just barely does that. Start picking up. And I'm going to grab my 12-point wrench to just break them free and loosen this up a little bit so that I'm able to drop it down to where it needs to be and actually bolt it into place. Oh, this one fell out of its little cup, so you got to pay attention to that. So I'm just going to lightly snug these. And then these two bolts are at a different angle than this bolt. This bolt comes in kind of funny, so I have to leave that one out for last in order to install it. And then, of course, listen to the specs from the rocker arm company. This one particularly is Jessel for torquing these guys down. Now, if you end up in one of these particular scenarios where you have the type of build where this area has to be cut away to make room for this spring guide area, preferably find a better rocker that can clear it. If for some reason that's not an option for you and you have to have it cleared, then make sure that when you have the slack in the rocker here that you can feel nothing contacting right there. And then, of course, while you turn the motor over, you want to watch this area versus the spring, because usually it will touch as it's just starting to push it down. So I'll go ahead and turn the motor over so you guys can see as this one comes back up what I'm talking about. So right here, it's just about to the top, and it comes kind of close to that, but because I've already clearanced this one, it stays quite a ways away. I made sure I had enough clearance without getting rid of too much to cause an issue with this guy. This was one of those scenarios where it just barely touched the rocker, and I was willing to just go ahead and carve away rather than get a whole new different set of rockers and have to redo everything for the setup. And that was way back before I was willing to be patient enough to do different rockers. So now, from now on, I'll be doing different rockers if I have an issue like that again, or different spring cap cover, spring retainer setup than what I had on this particular motor. So I'm going to go ahead and turn it a little bit more. And you can see now I'm at the top. And it comes closer at the top here now because I cut away that little section down there. But it used to come closer down in this area versus up here. And of course you want to check that on all of the Valvetrain. Make sure all of them clear with plenty of clearance. And then another thing you should have the machinist measure is if you know what your lift is going to be, you need to take, and when the engine is at maximum lift, you have to make sure you have plenty of gap between the springs to make up for expansion and contraction, because you don't want to over collapse springs to the point where they bind. If they bind, obviously that will lead to catastrophic failure. So make sure you don't do that. See a little piece of hair here. Darn hairs float around everywhere. And then of course, as I said, when it comes to actually getting the correct push rod length and the correct height here, you have to make sure that roller is riding on the right spot of the lifter. And I'll go ahead and overlay the video I was just showing you guys to give you an idea of what I'm talking about. You can see how the roller is actually riding basically in the middle of the valve stem. It might be a little off to one side, but I'll be verifying that a little bit closer here. I don't think there's anything I can do about it just because of the nature of how this particular motor is. I don't know if I can find the right shim combination, but I will do my best to get it as close as possible. And with that, like, share, subscribe. Thanks for watching. I hope to see you on the next episode.